Okay, let us start eigenvalues and eigenvectors. What is the definition of eigenvalue? Write down the definition. If A be a square matrix of order n, if A be a square matrix of order n, then the value of lambda for which the equation Ax equal to lambda x has non-trivial solution. X equal to lambda x has a non-trivial solution. Solutions are called eigenvalues of matrix A. So for finding the eigenvalues, the matrix should be a square matrix. So if A is a square matrix of order n, that means A is a square matrix of order n means A is a matrix whose order is n by n or n plus n. Then the value of lambda for which the equation, this one, satisfying, or for which the equation Ax equal to lambda x has a non-trivial solution. Non-trivial solution means here the x should be non-zero, because non-trivial solution means for any x it will satisfy, that is a solution, but I am interested in non-trivial, that means for those non-zero x for which x equal to lambda s, and these values of lambda are called eigenvalues of the matrix A. Similarly, what is eigenvector? The same way, here the x is called the eigenvector. So what we will write, if lambda is an eigenvalue, then the non-zero vector x, for which equation 1 satisfies or equation 1 holds is called eigenvector, or are called eigenvectors associated with the eigenvalue lambda. That means for those values of lambda which satisfy Ax equal to lambda s for non-zero x, and that x is called the eigenvector associated with this eigenvalue lambda. And also these things have some different name also. Eigenvalues are also called as characteristic values, or proper values. Characteristic values are proper values. And eigenvectors are also called as characteristic vectors. Or proper vectors. Similarly, there are other terms like characteristic polynomial and characteristic equation. So what is my characteristic polynomial? Suppose A is n square matrix. Suppose A is n square matrix of order n, then characteristic polynomial of A is given by, this is your determinant of A minus lambda I or A minus lambda in. In stands for identity matrix of order n. So determinant of A minus lambda I or A minus lambda in, this is your characteristic polynomial, and characteristic equation is your determinant of A minus lambda in. If this thing is equal to 0, then this will be your characteristic equation. Okay, so we got what is your characteristic polynomial and what is your characteristic equation. Similarly, there is another definition. This is the definition of eigenspace. So what is the eigenspace? The eigenspace of an eigenvalue lambda is the collection of all eigenvectors associated with the eigenvalue lambda. So eigenspace is the collection of all eigenvectors associated with the eigenvalue lambda. So it is denoted by E lambda. E stands for eigenspace for eigenvalue lambda, and this is those V or those X. This is the collection of eigenvectors. So we can write this E lambda is equal to those X such that A into X is equal to lambda X. That means this is the collection of all eigenvectors X which satisfies this Ax equal to lambda X. That means which are the eigenvectors of X. So this is the definition of eigenspace. Now we'll go to a problem. Now solve a problem. Example, let A find the eigenvalues and eigenvectors of a matrix A. Find the eigenvalues and eigenvectors of a matrix A, where A is equal to 1 minus 1 2, 1 minus 1 2, then 0 1 0, then 1 2 1. And this is a matrix having order 3, and this is a square matrix of order 3. Then how we will find its eigenvalue and eigenvectors, and also here we will find what are the characteristic values and characteristic polynomial. So first calculate what is determinant of a minus lambda I. Now determinant of a minus lambda I or lambda I3. This is your determinant of a is 1 minus 1 2, then 0 1 0 1 2 1. A minus lambda I3 stands for identity matrix of order 3. So this will be your 1 0 0 0 1 0 0 0 1. Then this will be your determinant of this is 1 minus 1 2 0 1 0 1 2 1 minus lambda times identity matrices lambda 0 0 0 lambda 0 0 0 lambda, and then this will be determinant of subtract this matrix from the first one, that will be 1 minus lambda minus 1 2, then 0 1 minus lambda 0 1 2 1 minus lambda, determinant of this one, and determinant of this one. This is determinant of 1 minus lambda minus 1 2, then 0 1 minus lambda 0 1 2 1 minus lambda. Determinant of this one is equal to 1 minus lambda whole into make this product. This is 1 minus lambda whole square minus 0 1 minus lambda whole into this one, then minus 1 whole into 0 0 0 minus 0 plus 2 whole into, you know how to find the determinant, then 2 whole into this is 0, and this one is minus of 1 minus lambda, minus of 1 minus lambda. So this will be your 1 minus lambda square minus 0 is 1 minus lambda square, so 1 minus lambda whole cube, and this one is 0, and this is minus 2 times 1 minus lambda. So 1 minus lambda taking common, this will be 1 minus lambda whole square minus 2. This is 1 minus lambda whole into 1 minus lambda whole into, and this, what is this one? It's 1 square plus lambda square minus 2 lambda minus 2. So this will be 1 minus lambda, this is lambda square minus 2 lambda minus 1. So determinant of a minus lambda a, this is your characteristic polynomial. That means our characteristic polynomial is this f of lambda, which is equal to 1 minus lambda whole into lambda square minus 2 lambda minus 1. Then what is your characteristic equation? Your characteristic equation is, if you will put this, if you will write this f of lambda equal to 0, this is your characteristic equation. That means this is your 1 minus lambda whole into lambda square minus 2 lambda minus 1 equal to 0. This is your characteristic equation. And how you will find the characteristic polynomial, characteristic value or eigenvalue? So if you will find the values of lambda from the characteristic equation, you will get the characteristic values. Okay, so now write the characteristic equation. This is your 1 minus lambda whole into lambda square minus 2 lambda minus 1 equal to 0. So 1 minus lambda equal to 0, or lambda square minus 2 lambda minus 1 equal to 0. So if 1 minus lambda equal to 0, then your lambda is equal to 1, and if this one equal to 0, then find the values of lambda. and I can write here lambda is equal to minus b plus minus square root of b square minus 4ac by 2a formula. So minus b will be minus of minus 2 plus minus square root of b square, that is your 4 minus 4ac, 4 into 1 into minus 1 by 2a is a 2 into 1. So this will be 2 plus minus square root of 8 by 2. This will be 2 plus minus, this is your 2 root 2 by 2. So after cancelling 2, it will be your 1 plus minus root 2. Okay, so what are the eigenvalues here? So the eigenvalues are, lambda 1 equal to 1 and lambda 2 equal to 1 plus root 2 and lambda 3 equal to 1 minus root 2. Since this is a matrix of order 3 cross 3 or this is a square matrix of order 3, so we will get 3 eigenvalues. What is the order of that matrix? We will get maximum, since it has order 3, so we will get maximum 3 eigenvalues. So that may be distant or may be repeated, but we will find a maximum 3 eigenvalues. So here the 3 eigenvalues are 1, 1 plus root 2 and 1 minus root 2. Now find the corresponding eigenvectors, and you know how we have to find the corresponding eigenvectors. We will find the corresponding eigenvector by the formula Ax equal to lambda x. Now we will find the eigenvector for Ax. First we will find for lambda 1 equal to 1. So for eigenvalue lambda 1 equal to 1, so our formula is Ax equal to lambda x. So Ax equal to lambda 1x, and your what is your A matrix A? This is 1 minus 1 2, then 0 1 0 0 1 0, then 1 2 1. This is your matrix A. Then your X matrix is your column matrix x1 x2 x3. Since it is a 3 cross 3 matrix, so there will be 3 variables x1 x2 x3. And what is your lambda 1? Lambda 1 is your 1 and your x is x1 x2 x3. And then multiply this A matrix with X matrix, so this will be your x1 minus x2 plus 2x3. Similarly, middle one is your simply x2, and last one is your x1 plus 2x2 plus x3. This thing is equal to x1 x2 x3, because after multiplying 1 it will be same. So now this is a 3 cross 1 matrix, this is a 3 cross 1 matrix, and two matrices are equal, means its entries are equal. That means we can write this thing as x1 minus x2 plus 2x3 equal to x1, and x2 is equal to x2, and this x1 plus 2x2 plus x3 equal to x3. So we will find x1 x2 x3 here. Here is x1, here is x1, so we can cancel it. So what we will write? Only minus x2 plus 2x3 equal to 0, and here x2 equal to x2. No meaning, it has no meaning. And here x3 and x3, we can cancel the x3. So this will be your x1 plus 2x2 equal to 0. So this implies here we can write both x3 and x1 in terms of x2. So we can write 2x3 equal to x2, 2x3 equal to x2. This implies your x3 is your what will be it? Half times x2. Similarly, from this one here x1 is your minus 2 times x2. So we have written here x3 in terms of x2 and x1 in terms of x2. So now my x is your x1, x2, x3, which is your, in place of x1 we can write minus 2x2 and x2 is as your x2 and x3 is your half of x2. So taking x2 common, this will be minus 2 1 half. So if I will multiply 2 here, since this is a fraction, so you can multiply anything here, so or you can leave it as it is. So what will be x2 not equal to 0, because we are interested in non-zero eigenvectors. So what will be the eigenvalue associated with your lambda 1 equal to 1, that is your eigenspace of 1. This is your span of minus 2 1 comma half, difference 0. That means the any span of this one means any scalar multiple of this one except 0. That means the non-zero vectors, only the non-zero vectors which are the scalar combination of this one. The scalar combination of this one means if you will multiply 1 here, then this will be a vector, this will be an eigenvector of lambda equal to 1. If you will multiply 2, this is again an eigenvector of 1. If you will multiply any scalar, then this will be a eigenvector associated with this eigenvalue 1. Similarly, find for other eigenvalues. Then for lambda 2 equal to 1 plus root 2. So if your lambda 2 is 1 plus root 2, then similarly find the corresponding eigenspace associated with this lambda 2. So this will be your ax equal to lambda x or lambda 2x. Your a is your 1 minus 1 2 0 1 0, then 1 2 1, and your x is your x1 x2 x3, and your lambda 2 is 1 plus root 2, and your x is x1 x2 x3. So now what will be your ax? This is your x1 minus x2 plus 2 x3, and then second row is your x2, and this one is your x1 plus 2 x2 plus x3. So this one is equals to 1 plus root 2 times x1, 1 plus root 2 times x2, and 1 plus root 2 times x3. So if you will equate this thing, then what we will get? Your x1 minus x2 plus 2x3 equal to 1 plus root 2 all of x1. Then your x2 is 1 plus root 2 of x2, and your last one is your x1 plus 2x2 plus x3 is equal to 1 plus root 2 of x3. Now what we will do? Make the right hand side 0. That means what are present on the right hand side, you just shift it into left hand side. So what you will get? So this is on the right hand side, then bring it into left hand side. Then what you will get? This is x1 plus root 2 x1. So x1 cancels, so only it will be minus root 2 times x1, then minus x2 plus 2x3 equal to 0. And if you will bring this thing to the left hand side, what you will get? Minus root 2 of x2 equal to 0. And similarly, the third one is x1 plus 2x2 minus root 2 x3 equal to 0. So from these three equations, what you got? Here root 2 times x2 equal to 0. This implies your x2 equal to 0. So in these two equations, you just put here x2 equal to 0. So it will be minus root 2 x1 plus 2x3 equal to 0. And the third one is x1 minus root 2 x3 equal to 0. So what we got here? Here x1 is root 2 times x3 and here x2 is 0, and what we are getting from this one, here root 2 x1 is equal to 2x3. Here x2 is 0, but these two things are equal. If you will multiply root 2 here, then it will be root 2 x1, root 2 x1, and then root 2 into root 2, this is 2, this is 2x3. That means we are getting only two things. One is x2 equal to 0 and another one is x1 is equal to root 2 x3. So what will be my x now? So my vector x is equal to, which is your x1, x2, x3. This is nothing but in place of x1 we will put root 2 x3, and in place of x2 we will put 0, and in place of x3 as it is x3. So now taking x3 common, this will be a root 2 0 1, where x3 is not equal to 0. So the eigenspace of root 2 plus 1 or 1 plus root 2 is, this is the span of root 2 comma 0 comma 1 except 0, because we are interested in non-zero eigenvectors. So this will be the corresponding eigenvectors. Eigenspace means the set of all collection of all eigenvectors. And then for lambda equal to root 2 minus 1, similarly we will not evaluate it and we will write only. So for lambda equal to root 2 minus 1, we can do it in similar ways, and can find your eigenspace of 1 minus root 2, eigenspace of 1 minus root 2. For 1 plus root 2, this is this one. So similarly, if you will find for 1 minus root 2, it will be just a minus sign here. This is minus root 2 comma 0 comma 1. So if you will find, so if you will proceed in the above way, then you will find this will be your span of minus root 2 0 1 and only this 0 vector. Then these are the all eigenvectors associated with this eigenvalue 1 minus root 2. So these are all. These are all about the eigenvalues and eigenvectors and the characteristic polynomial, characteristic equations, all are these. So